Example 3. Solve the following absolute value equation. A, algebraically, and B, graphically. So graph it and solve it algebraically. So first things first, let's write down the equation. Absolute value of x squared minus 4 equals 5. So A, algebraically. Now it is very much the same as solving a linear equation algebraically, because you'll notice that this is a quadratic because we have x squared. Okay, so this is essentially going to be a line intersecting with a quadratic. So first things first, we want to isolate the absolute value, which it already is. So thank you, mathematical gods. Thanks for giving us that. Then we need to split it into two different sections. We need to have the negative x squared minus 4 equals 5, and we need to have the positive x squared minus 4 equals 5. Now I'm going to solve both of these branches and see what solutions pop up. So I'm going to distribute that negative, so it's going to be negative x squared plus 4 equals 5. Subtract 5 from both sides, so negative x squared minus 1 equals 0. I can multiply through by a negative 1, so that becomes x squared plus 1 equals 0. Now let's try to solve this. If this were a difference of squares, if this was a subtraction, we'd be able to solve it. But it's x squared equals negative 1. Let's think about it. No value of x can produce, no value of x squared can produce the value of negative 1. So no solution. Let's go over to the other one. So we're going to subtract 5 from both sides. X squared minus 9 equals 0. Now we're going to solve it. Well, we're going to factor it first. X plus 3, x minus 3, because it's a difference of squares, equals 0. So therefore we know that x equals negative 3 or positive 3. Another way we could have written it is positive or negative 3. So there are two solutions. This is it. Now when we're asking for the solutions of an equation, we're asking for the x values. So that's going to be helpful when we start doing this equation graphically. So let's graph it. So first things first, we want to have y1 equals x squared minus 4, the absolute value of x squared minus 4, and then we're going to graph a second equation equaling 5. So we take this whole equation here and we set one side equal to y1, we set one side equal to y2, and we treat them as two different functions intersecting. So what we want to do is we want to graph this one and we want to graph this one. So let us use the control paste. Yeah, that's what I'm talking about. I'm going to move that right over here. Come on now. There we go. So I'm going to graph both of these equations. Now one of them is really easy, the y equals 5. It's just going to be and I'm going to change the color. I'm going to change that to red. Y equals 5 is simply a straight line at y equals 5. Boop, boop. I'm going to take the graphing of this absolute value in chunks. So my vertex I know is going to be at 1 and negative 4 for the original one. So I'm just going to say first I'm going to graph y equals x squared minus 4. There's no stretch factor, so we go over 1 up 1, over 1 up 1, over 2 up 4. I think I graphed this a little too low. 1, 2, 3, 4. Oh, good thing I checked that. Okay, here, here, and here. Over 2 up 4. over 2 up 4, over 3 up 9. Whew! I see an intersection point here. That is good. So this right here is our, we're just going to label it. This right here is our y equals x squared minus 4. What about our x squared, the absolute value of x squared minus 4? Well, we know that we take all of the points that are below the x-axis and we create them above the x-axis by multiplying all of the y values, or finding the absolute values of all the y values. So this one becomes positive 4, 0, positive 4. This one becomes 1, positive 3. This one becomes negative 1, positive 3. Notice that you can still have a negative x value, just not a negative y value. So when I graph this, this right here is our y equals the absolute value of x squared minus 4. So we're noticing the x values of where these two functions intersect. X is going to be negative 3 and x is going to be 3. So whenever we are solving for an equation, all we are doing is we are finding where the two graphs intersect. So I can say my final solution here is going to be x equals plus or minus 3.